Hello, everyone, and welcome back to the 2020 Bibliometrics and Research Assessment Symposium for the final session of day 2 of our symposium. I do have a couple of quick reminders for everyone just in case. We are recording this session, but the recording is not going to include either the attendees or the chat box, so you're free to continue participating in the session knowing that you're not going to be part of the recording that we make. Audio for all attendees is in broadcast only, so you don't need to join the audio session to listen in. But all attendees are going to be muted for the duration of the session, so we're handling all questions through the chat box. All questions related to technical issues can be asked in the chat, and all questions for our presenters can also be asked in the chat. But we ask that you please send your messages to everyone. We do have a number of folks monitoring the chat, looking for questions, looking for technical issues, and so forth. So please do send your questions to everyone to make sure that we see them and we're able to answer them and address them accordingly. Finally, we do have live captions available for the entire session. Those captions are available in the Multimedia Viewer panel in the lower right of the WebEx screen, and they're also available in the URL that my colleague Candice Norton just put in the chat box. So with that, we're going to jump into the final session of this particular day. So we have a panel of presentations on the funder perspectives in bibliometrics and research assessment. Up first is Karen Waite from the National Science Foundation. Karen, are you there?
Yes, I am here. And you can hear me?
I can hear you just fine, yes.
Great, let me share the screen and then I will put that into presentation mode and we'll get rolling. I want to thank everybody for being here. For us on the East Coast, this is happy hour, so, welcome to the happy hour presentation. I'm Karen White with the National Center for Science and Engineering Statistics, which is part of the National Science Foundation. I am also happy that my co-authors on the research part of this presentation, you heard from Cassidy Sugimoto earlier in this meeting. This is really fits very nicely in with the research that she has been talking about. And also my colleague Wanying Chang from NCSES is with us, and that's awesome because Wanying is really the expert both on the regression results, and we'll be talking about the survey of doctorate recipients, and she knows the ins and outs of that survey, but I am getting ahead of myself. So let me start off by giving some context. So this presentation will cover 5 areas. I'll give you a little bit on who is NCSES, just in case you haven't heard of us. We are a small little group. And I'll talk about what are indicators, and that's a report that we put out every 2 years. It's a series of reports, and one of those reports is trends in publication output. And I'll highlight some of the trends that we saw in our last report, which came out in 2019. And then I'll talk about data. We have a lot of data. As a federal worker, I work for you, and we have lots of free, useful data and analysis on our site ready to roll. Then I will talk about research we've done into the critical role of doctorate research assistantships for women and minorities and how that links into publications. So who is NCSES? We are one of the 13 U.S. principal statistical agencies, and we reside within National Science Foundation. We focus on science and engineering data. We put out a publication called The State of Science and Engineering Indicators. It's actually a series of publications, and we summarize the state of S&E January even number years with a report to the President and Congress. That's our sort of the state of S&E is our high level report. Then we have a series of reports that support that submission to the President and Congress. And that series of reports includes data and analysis on R&D performance, funding, R&D output, invention, knowledge transfers, STEM education, both at the K-12 and higher ed levels, and public attitudes towards science. So now I'll talk about some of the high-level results that we have in our publications output U.S. Trends and International Comparisons report. And here you'll see that, you know, as we know, it's a growing mountain of publications. In 2018, it reached 2.6 million publications. This is from the Scopus data set. All major scientific research countries experienced an increase from 2008 to 2018, with the exception of Japan and France that had slight declines. The world average growth rate was 4% over that period from 2008 to 2018. In comparison, the U.S. average annual growth rate during that period was less than 1%. Most of the growth rate during that time period came from China and India. China had an average annual growth rate of 8% per year. India had an average growth rate of 11% per year. And looking at the rest of the world, which is that top slice up there, that grew at 6%. So clearly research is growing fastest in countries that are newer to the research scientific enterprise. Research capacity is growing around the world. So we have data on publication output by country. Basically, we have every country listed. And we also have these breakouts by 14 different scientific fields by country. So if you want to know how many papers in agricultural sciences were produced in Russia, you can find that out in our data sources, in our supplemental tables, and I'll tell you how to get to those shortly. So we talk about that growing capacity of research, and one of the other ways to see that is to look at international collaboration. And international collaboration among researchers indicate the expanding research capacities around the world. Researchers collaborate for a number of reasons, including access to a desirable collaborator, access to costly or shared equipment, or a condition attached to research funding that requires international collaboration. I'm going to cite Carolyn Wagner for that handy list of why people collaborate. In the United States is the largest producer of international collaboration papers. In 2018, the United States produced 215,000 papers with a partner from another country. Other countries have larger percentages of their publications with international collaboration. For example, 62% of the UK's publications involved international collaboration. The U.S. collaboration rate was about 39%. You can see differences as you look across these different countries, and it changes by country size, geography, maturity of the scientific research in that country. In other words, how likely are you to be able to find a collaborator within your country? And the U.S. collaborates most frequently with China in 2018, and that was about 20% of U.S. collaborated articles had a Chinese co-author. So where can you find this data and so much more? So the URL is up here at the top, and what I'm showing here is a page from my report that has the data and all these tables. There are actually 50 supplemental tables. It's hard to see all at once. And this is going to be true for each and every one of the reports. We have a total of 8 reports plus the summary report, which we call the State of Science and Engineering, and that's there in the circled in blue. You can get to that page. And for any of the reports, R&D, invention, innovation, those reports, you can always find the author very easily. This is our new designed webpage, so we try to make things very easy. And I hope you have an opportunity to check out our page and find lots of data. So now I'm going to switch focus and switch gears to talking about current research underway. And I'm going to put up this disclaimer because this is research for a forthcoming article. In other words, it's not going to be coming out as an NCSES product. So I'm taking off my statistical agency hat and putting on my researcher hat. And this portion of the presentation represents findings undertaken by the staff at the National Center for Science and Engineering Statistics and Cassidy Sugimoto, who was at that time the head of the SciSIP program in the Social Behavior and Economic Sciences Directorate. She's now returned to University of Indiana. And the views expressed are those of the authors and do not reflect those of the National Science Foundation. So, what did we look at? What we did is matched the survey of doctorate recipients to the Web of Science. This gave us an enormously rich data set in the survey of doctorate recipients. We knew employment situation, where they're employed, how they're employed, if they're in academics, faculty rank, tenure status, principal job, salary, benefits, funding level, and we also have a wealth of demographic information: gender, race, ethnicity, citizenship, marital status, children, functional limitations. So we know this, and this comes from survey data, which is going to give us that really high quality information on gender, race, ethnicity. We're not trying to guess the race and ethnicity using their names. And as I mentioned, Wanying is in this meeting and available through the chat for those of y'all who are interested in learning more about the survey of doctorate recipients. We match this up with the Web of Science, and people in this meeting are going to be well aware of the peer-reviewed article and conference proceedings that are available there. So we take the name and research area and affiliation, and that's what we're going to use as our matching criterion. On the right-hand side, you see that we're getting publication, citations, institution, and of course we can determine what country that institution is in, and we can also find co-authorships on the article, standard stuff. The exciting thing is being able to link that over to the survey of doctorate recipients to get gender, race, ethnicity, the degree that they graduated in, what field did they graduate, did they graduate from a high research institution, age at graduation, the year of their degree, marital status, if they have children, citizenship status, and primary support, what support did they use to fund their graduate school. So we start with over 81,000 survey of doctorate recipients and respondents to that survey, and using random forest, that gets linked up to the Web of Science. For that time period, there are over 52 million publications, but that quickly comes down to about 17 million after applying the initial name block. And so we use the last name and first name block to set a gold standard and then there are refinements such as adding email address matches, and and I'm going to call out to Joshua Snell, who I think is also on this call, though help in making these matches was work with Clarivate. And so we end up with a very nice large database with almost 57,000 matched author names, and that links up to about 1.5 million matched publications. So let's see what this means for considering publications in the career path of PhD graduates moving into academic and non-academic situations. So we use a likelihood regression, focusing on the variables that we saw back in slide 9, with the addition of name frequency to capture potential issues with matching common names, which could yield a false positive. So, okay, this graph can look a little bit like rush hour on the Beltway, but pausing to focus, we can get some valuable insights. Notice the bright red and start at the far left. These are PhD graduates who end up in R&D academic jobs within 7 years after graduating. Now follow that bright red line, and you see that these PhD graduates are more likely to move into academic positions, and that they are more likely to have had more than one or more publications when they were in their pre-PhD time period. So, and then they go on and they tend to have more post-PhD publications as well. So this is showing that training matters. If you learn to write a paper as a pre-PhD, that prepares you for academic positions with R&D and reinforces the probability of publishing later in the career. Now, it's also really interesting to look at the pinkish or salmon-colored lines, again, starting at the far right. This is the group that moves into non-academic R&D. Note that it is the thickest part of the line comes from those who have at least one publication in their pre-PhD period. This is showing that even for those who move into non-academic R&D, having a pre-PhD publication is indicative of having a job 7 years after graduation in R&D. Indeed, we find that those with pre-PhD publications, 56% reported their first job in R&D, compared to only 37% of those without a publication. Overall, the chances of having an R&D position within or outside of academics, at least 7 years after graduation, increases significantly for those with both pre- and post-PhD publications. Okay, so that was nice. We've clearly shown a link between publishing and career trajectories, very unique to this data. In our upcoming paper, we go beyond this analysis and look at the role of race, ethnicity, and gender. Our research and the previous research discussed today shows that the propensity to publish is not uniformly distributed across minoritized populations, with white and Asian males having a higher propensity to publish compared to Black, Hispanic, and women. Let's go one level deeper and look at the training of the PhD candidates. Turns out that if you have a research assistantship, you are more likely to publish before completing your PhD. Wow, so this has the potential to inform key policymakers about how to broaden the diversity of the R&D workforce in the future. With that, I thank you for your time and your attention and welcome any comments and questions.
Thank you, Karen. Okay, we have a question from the audience. So we're curious if the international collaborations represent authors living in different countries or authors with different nationalities but living or working in the same country.
So how we determine collaboration is looking at the institution of the authors. If that institution, we use the country in which that institution resides. So you may well have someone who is from another country, perhaps doing graduate work in the United States. If they say that their research affiliation is UC Berkeley, we will not tag that as international collaboration. But perhaps when they return to their home country and the Shanghai University, then we will refer to that as international collaboration.
Great, thank you. I think we have to move on. So thank you, Karen. We still have a few questions in the chat, so please come over looking at the chat and have more conversations with the audience. Thank you.
Yes, thanks again, Karen, for a great presentation. So up next, we have a dual presentation from Carmel Goldberg and Ariadne Legendre. I hope I didn't butcher that pronunciation too badly. But Carmel, they are both from the Social Sciences and Humanities Research Council of Canada. So Carmel, I know you're starting off the presentation. So are you around? Are you there?
She's still on mute, it looks like, so maybe.
I can unmute you, Carmel, if that would be easier.
Hi, can you hear me?
I can hear you.
Great, sorry about that, those last minute technological issues.
No problem.
So we're really, really happy to be here today. My colleague and I, Ariadne Legendre, are here to present a pilot research landscape analysis we conducted in collaboration with Clarivate Analytics. So a quick shout out to Melissa Day and to our colleague Thérèse de Grotte, who are in the audience right now. So Ariadne and I work for the Social Science and Humanities Research Council. It's a Canadian research funding agency whose mandate is to promote and support post-secondary based research and training in the social science and humanities. One of our signature initiatives is called Imagining Canada's Future, and it's an initiative that mobilizes social science and humanities research to address emerging and future economic and societal knowledge needs for Canada and to help guide decision-making across all sectors for a better future. So following an extensive foresight exercise that we conducted in 2017, we identified 16 global challenges which Canada is likely to face in the coming decades. There was a strong convergence of interest generated in the topic of living within the Earth's carrying capacity. So here's the framework for imagining Canada's future, and it includes activities within 3 pillars: foresight on societal futures, research on emerging issues, and futures of research. So this bibliometric study recognizes cross-divisional and collective efforts at SSHRC that will contribute to advancing priorities relevant to futures in research and training. And the work on the challenge of living within the Earth's carrying capacity stimulates research preparedness and supports SSHRC's priority to seek collaborations and partnerships with other governments and departments and across stakeholders. Ariadne, your turn. You're up.
Yes. Hi, everyone. In order to measure the objectives of Future Challenge, we want to look at what's the contribution that SSHRC is bringing to this, what Canada is bringing to this within the global landscape of living within Earth's capacity. And given that it was such a broad, complex theme that's very multidisciplinary, a bibliometric study made sense. And having said that, SSHRC in the past has not used the bibliometric study very much or at all, basically. So we're very new in this, and this is somewhat of a pilot study to understand how we can leverage the data from these type of analysis better, and we're hoping to get a little bit of your expertise at the end. So the objective of the analysis was to, first of all, understand at the global landscape stage what is going on in living with an Earth's carrying capacity. Then understand what is Canada's contribution and what are Canadian researchers' contribution within that global landscape. And obviously, we work for the Social Science and Humanities Council, so we want to understand what is the role of social science and humanities within living within Earth's capacity. And the idea was to be able to monitor that over time to see the changes. So, given that the challenge of living within Earth's capacity is such a broad challenge, it also provides a great opportunity to look at questions like the changes in global ecosystems, the mitigation and adaptation strategies, or decreasing biodiversity and disruptive weather pattern, and the absorptive and productive capacity of global ecosystem, and much more. So because of that, we did work with Clarivate on this, and this slide shows part of the term search that was used to pull over 38,000 documents from Web of Science. And this 38,000 made up our Living Within Earth's Capacity data set. And what we found was that the Living Within Earth's Capacity over the last 5 years or 6 years almost over doubled its contribution to the publication world. So, and what we were actually we were happy to find was that social science and humanities represented over 60% of that contribution. So that made us very happy. And not only that, but the data showed that most of these were very multidisciplinary. And then when we looked closer at how Canada ranked against the other countries, we found that Canada was above the average and was close to what Portugal and the UK is producing. And this is important like this as a funding agency, because you can, as we're going to maybe look into different collaborations, international collaboration, this can kind of tell us maybe, what countries are doing what and how maybe inform some of those collaborations. And then when we looked at specifically what Canada's contribution were in what type of subject area they were, we saw that we were the strongest in policy science and health and in evolutionary biology. And what we can see from this graph also is that the economic may present, although there's less publications, they are more impactful and maybe an opportunity for the future to collaborate with fields in economics. And then finally, we looked using the Clarivate research front. We found 363 Living Within Earth's Capacity papers within 250 research fronts, and 63% of them were in SSH citation index, and 65% of them were from Canada. So that's kind of, this data we know we're just kind of starting to scratch the top of it, and we're starting to deep dive in what are we going to do. So all this data is really good, but so what, right? So then we want to understand how does it compare to SSHRC's data? So we looked at our own data, and we took, based on text analytics, we made this baseline for the last 5 years, and we found these 4 clusters. So again, just scratching the surface of what we can dig in to understand the gaps and the opportunity for the future, but also to inform potential engagement that we would do with our community. So here what we did is a keyword comparison using keywords from a knowledge synthesis grant, which was a funding opportunity specifically linked to living within Earth's capacity. And these were, the call was made up with the help of experts in that field. And this is the keywords we got. And then if you move to the right, we have SSHRC's 5-year baseline. So the data set that I showed previously, these keywords came from there. And I have to say that the way that the baseline was created was using a technology based on similarities from the results that we have received from the KSG. And then at the bottom left, you have the keywords from the most popular keywords from the 38,000 articles that we found from the Living Within Earth's Capacity data set. And then at the bottom right, we have the research fronts that were from Canadians in FSH. And what's interesting here is if you compare what the experts that were funding at SSHRC, so the KSG at the top left, with the bottom right, which is the hot stuff from Canada in FSH in that same landscape of Living Within Earth's Capacity, you can start to understand where the gaps were, the similarity, and potential opportunities for the future. So I'll leave it to that. Again, we're just scratching the surface, and we really would like to have your insight on, what could be the next steps for us in this, and what do you think about our methodology overall? So I'll pass it back to Carmen on that note.
Great. So that's kind of where we're at. We're really starting to explore and to look at the relationships between different types of data sources. And now we've explained to you a little bit about our data sources, and we'd like to see if you have any, we welcome any kind of feedback you have on this preliminary study, as well as we're looking for recommendations on next steps based on your relevant expertise. We have 3 kind of big bucket areas that we kind of thought of, but of course there might be other areas that you suggest. So the first is, how can we further explore trend trajectories, whether it's over time, a pre-post model? Is there a way to look at how these data link to potentially to Canada's social and economic recovery in the era of COVID-19. We're interested, as Ariane said, to do some, co-authorship analysis to be able to understand the structure of the Canadian landscape and areas that we could reinforce, maybe looking at, whether it's trainees versus, more senior researchers, small institutions, big institutions, those types of things. Or also we're interested in triangulation with other data. So we know a little bit about, we haven't explored very much about altmetrics and dimensions platforms, but being able to look a little bit downstream at downstream impacts and the contributions to policy, as well as maybe even some of the traction that might exist in the media or social media on some of these themes. So unfortunately, Ariane, I'm going to let you read the screen and the questions and suggestions people might have, because as I'm sharing my screen and I don't see the chat.
Yeah, right now there's no questions. So.
Oh. Okay.
But the point was, if you have insights for us, we'd be happy to hear it.
Yeah. here are our email addresses as well. You could get in touch with us. We are very interested in further exploring this data, and feel free to email us if you think about ideas or have suggestions for us after the fact. I think I see a question that flashed on the screen.
Yeah, that one is a question. It says, there is a question that the moderator may not be able to see from Laura. Hi, what did you use for your keyword analysis? So we basically used just the most relevant, the keyword that came back the most often, and we only took the top 20 in each data set.
So that would be for the data set that was in Web of Science, and we used it within that first layer within SSHRC-funded research. Perhaps, Ariane, you could talk about the neural net and the text analysis and some of that.
Yeah, no, we still use, like, the neural net was used to find the data set, and then from that data set we went and got the keywords that were most often cited from that data set. So we try to use the same methodologies for each quadrant in here. So we have another question. It says, I missed how you search for a topic like living with an arts capacity. So we, based on the call that we did, the knowledge synthesis, we had a nice idea of what at SSHRC think of living with an arts capacity, and based on that we were able to pull a bunch of search terms on that, on Web of Science, but also on our own data sets.
What I would add to that is we assembled a group of experts in the field of living within the Earth's carrying capacity. So these would be academics. We also invited public servants, experts from the non-for-profit and private sector to help kind of frame that call for a knowledge synthesis grant. And so that's really what defined what experts wanted to know here and now within this large theme.
Oh, we have another comment here. The comment says, I think one of the most interesting pieces to explore next would be to analyze the academic research department involved, both in terms of cross-department involved, both in terms of cross-disciplinary of papers, also just representation across traditional discipline. You've done some of this already, right? Not yet, actually. We're just just scratching the surface. And we're kind of trying to decide what is going to give us the most bang for our buck for how we're going to use this data in the future. But I think that's a great suggestion.
Some of that was done by Clarivate.
Melissa also commented that the Web of Science, Melissa from Clarivate, that Web of Science iterated with SSHRC to develop a list of keywords that so that was on the search term. So we worked together to really have a nice keyword based on that call from the experts. It's a great suggestion. Thank you.
If I might jump in.
Yeah.
It strikes me that in thinking about other things you might be able to do with this, so many of these topics are related to things like legislation, policy, social implementation, working with communities, those kinds of things. I wonder how much you might be able to link some of these publications to things that maybe the government is doing or maybe local communities are doing to try and sort of implement some of this. I don't know how on earth you would do that, but that might be a direction you might want to take.
Mm-hmm. So that would definitely talk to the impact of some of these publications too.
And would we do that through, more of that altmetric approach to be able to, any ideas on how we would do that to get a better understanding of, how communities are approaching this?
Yeah, I'm, again, just trying to think out loud here. You might be able to find some of those kinds of links in things like altmetric or what Ewan was talking about in Overton, citations of policy documents. That might give you a starting point, but I wonder if some of it is just like reaching out to the people who are doing this research and saying, hey, how are you sort of trying to move this forward into actually, how do we actually do things? Anyway, just some thoughts.
Yeah, that's great. Yeah, we know there's lots of different ways we could dig into this data. So we have another question that was, you could probably do some text mining for key terms, no organization in the abstract in the Web of Science record you already have. Yes, that's definitely on our plan to do that. And I'm actually very interested in comparing the technologies we found, or the clusters that we found in our organization, and compare it to the Web of Science data set. So yeah, that's a great suggestion.
Absolutely.
So I think we're going to have to leave it there. So thank you all once again for a really great presentation. And we're now going to move on to our final presentation of the day. Last but most certainly not least of the day, we're now going to hear from Anna von Gulick from Digital Science and Figshare about some work that they've done around tracking data sharing. So Anna, are you here?
Yes.
Great.
Thank you, Chris. And let me present this. I go into full screen mode. Does that look right?
Looks great to me.
Okay, perfect. Hi, everyone. My name is Anna van Gulick. I am the Government and Funder Lead at Figshare. And I'm the only one presenting today, but this is work done with some of my colleagues at Figshare and at our parent company, Digital Science. So Mark Hannell and Dwayne Williams. You heard from Dwayne in the previous session. And so you've heard about some of our sister companies, Dimensions and Altmetrics, which I'll also mention in the context of Figshare. So my background is as a cognitive neuroscientist. I used to study the high-level visual system, and then I worked as a librarian for 5 years, focused largely on open data. And I joined Figshare at the beginning of this year to work with a lot of our government and funder clients, both public and private funders. And so today I'm going to tell you, talk a little bit about, oops, go into this. There we are. Gone too far. All right. Talk about kind of the broader landscape of data sharing briefly and the growth of that area. Then I'm going to talk about the NIH Figshare, and there's a typo there, Figshare instance, which was a pilot repository that we did with NIH last year. I'll talk about the features of that repository and some of the lessons we learned. And then also talking about how this is sort of the beginning of bibliometrics for open data, what we're doing now and what the opportunities are for the future there. So briefly, looking at data sharing adoption, this is a survey that we conduct together with Springer Nature each year. It's called the State of Open Data. And actually, we're going to be releasing the new one, I believe, later this month for 2020. But if you look at the data from the State of Open Data in 2019, we can already see a really steady growth of data sharing adoption. So when asking researchers, how frequently do you make your data openly available to others, have more than half of respondents saying that they do so always or most of the time. And there's a growing number of people saying that they do so at least sometimes. We can also look at the growth of data sharing by looking at DOIs in publications that are linking to generalist repositories. So this might be data or it might be any other item that's shared in a generalist repository. And if you're familiar with the data sharing, the repository landscape, you'll know that there's many discipline-specific repositories, including those supported by NIH, like GenBank and the Protein Data Bank, that are very specific. And then there's a number of generalist repositories that accept a wide range of data and other research materials, ranging from the humanities to the biomedical sciences and beyond. And so you can see a growth really across all of the generalist repositories, Figshare, Dryad, Zenodo, in particular, over the past couple of years, indicating that more and more products of research are being published and are being linked by authors in their papers. And then, of course, this is a figure from another workshop that you guys held, and thinking about just the volume of different types of research that need to be shared. So going beyond the publication, and then also beyond the data set, that people need other materials that are part of the research process in order to make research fully transparent and reproducible, and really to track the full impact of the work, for researchers to get credit, for funders to understand what it was that they funded. So this includes things like protocols, code and software, study data, instrumentation, multimedia files, and that's something that we as Figshare are interested in helping people share. Another reason we've seen such an increase in interest in open science is because it's being required. So not only are researchers interested from either desire to get more impact or from an altruistic open science standpoint, but also a number of funders and also publishers are requiring that data be made publicly available that either underlies the findings of a specific grant or a specific publication. And I know we're all eagerly awaiting NIH's forthcoming policy update on their data sharing. And similarly, sort of as we get to, I like to call it Open Data 2.0, the next wave of open data, there's now increasing interest in making research not just open, but also making it fair. So findable, accessible, interoperable, and reusable is what that acronym stands for. I know this is a priority of NIH and NSF and other funders. And I think we're all coming to the realization that just having data posted on a website with a Google Drive or a Dropbox link doesn't make it very reusable to others. People may find that link in a paper, but it can't be discovered by humans or machines, and it may lack the both the metadata as well as the documentation to find and reuse that data or recombine it properly. So now I think we're seeing an interest in ensuring that those standards are met, not just in really specific discipline repositories, but in generalist repositories as well, so that the open data can be more impactful. The other thing to note here is recognizing that open data needs to be as open as possible, but as closed if necessary, which is certainly an issue in the biomedical community, where personally identifiable information or other controlled data may not be able to be released fully to the public. And so thinking through what are the workflows to make it as open as possible, to make it discoverable, and then provide access as needed. Okay, so now I'll talk about the NIH Figshare instance. So firstly, briefly a note about what Figshare is for those who might not be familiar. So Figshare is a cloud-based platform for storing, sharing, and discovering research outputs. We have a free generalist repository available to researchers around the world to host their data and any other research materials on, and that's at figshare.com. And then we also provide policy-compliant infrastructure to other organizations, institutions, funders, publishers around the world who want to create custom portals to host research materials. So that's what we did together with NIH. So from July of 2019 to July of 2020, we ran the NIH Figshare instance, which NIH invited both intramural and extramural researchers to use to share the data, code, and other materials that were not publications or posters, but any other research products, to make them publicly available in a flexible generalist repository. And this was part of a initiative led by the Office of Data Science Strategy to address what the role of a generalist repository might look like in the NIH data sharing landscape. So this is what the portal looks like. You can see the data sets that were shared, include multimedia files, data sets, collections of many items, and this is at NIHFigShare.com. After the repository stopped accepting new user signups and new published data sets, we've since transformed it into the NIH Figshare archive. So the URL is the same. So if you go to NIHFigShare.com, just a note that this is what you'll see. And all of the items that were shared during the one-year pilot are preserved. They're still being actively tracked. Researchers can still edit and version them. We're just not accepting new items because the pilot has been completed. So the repository had a number of features. It builds upon our Figshare infrastructure for fair open research data. So standard fair metadata that's machine readable, open licenses, the ability to embargo data sets, common item level metrics, the flexibility to upload any file type, all of those things. And then we added some customizations and features that were specific to NIH. And so I'll highlight some of those. One of those that was really important was doing an expert file and metadata review. And this is something that a lot of our institutional clients choose to do, and it's something that we did in collaboration with NIH. So in this case, the NIH Figshare instance, researchers would deposit their research, submit it for publishing, then it would come to someone on my team at Figshare who have a background in data curation and biomedical research to review and to work with the researcher to make any changes before it was published and made publicly available in the repository. And what we focused on in that review was mainly the findability and the accessibility, and we focused mostly on the metadata. We think that's kind of the highest return on investment at the moment in increasing the fairness of data. So helping researchers choose things like a meaningful title, put descriptive things in, so that we don't have everything called dataset.xlsx, which isn't very discoverable and doesn't provide much context. But changing just that, adding an abstract, describing the methodologies can really be very impactful in someone understanding the context of that work and it being findable. So we also recommended other practices for fair open data as researchers wanted to work with us and just acted as guides for them through the data sharing process of using Figshare. We also had a number of custom metadata fields. So one of them was this drop-down menu to select which specific NIH institute or center funded the work. You could also select multiple, some of large grants funded by multiple institutes. And so that was custom. We also had a custom checkbox for researchers to affirm they were not sharing any personally identifiable information. So also something that we checked for during curation, but the main responsibility was with the researcher for that. There were custom item types in that the repository just took data, code, workflows, but not posters or publications. We also had custom categories that fit biomedical research, so people could select what categories their work was a part of, and specific licenses for reuse, including software and CC BY licenses. The DOI that was assigned to each item, which was permanent, citable, and versioned, was also specific to the NIH Figshare instance. So the prefix, this 10.3509/YHJC, was specific to the repository, which actually makes it easy then to track what's shared in the repository as well, because that is specific. And then we also made sure that specific NIH grants or intramural project IDs were listed since NIH funding was a requirement of using the repository. And here you can see the way that funding is entered in Figshare. So once you start typing into the funding field, it actually queries the Dimensions database and looks for those funding grants. So you can do this by grant number or by grant title, and then select the specific funding. You can also add multiple grants to that. So by creating that hard link to the grant information, that's really useful because someone can click on it in the data record, in the metadata, and they'll be taken out to Dimensions to see more information about the grants, what institution it was, who the investigators were, what the funding amount was, and who the funder was, all of those things, and that makes that then searchable in Dimensions, vice versa. The last defining feature of NIH Figshare was support for large file sizes. So we gave people 500 gigabytes of storage and more upon request, the flexibility to share any file type, and also ways to batch upload with an FTP or API. And while that's standard with Figshare, it was something that we found researchers really did take advantage of there. All right, so briefly, you can see that over the course of the one-year pilot, we did have more than 200 items shared, which I think it takes a while for researchers to learn about a new resource like this, so that was actually quite rapid adoption. And the storage used also increased rapidly, storing more than 1.5 terabytes across the project. We saw deposits from 22 out of the 28 different NIH institutes and centers, or maybe it's 27, depending how you count. If you count OD as a center, I've never been 100% clear. And then also seeing a significant number of deposits from intramural researchers as well as extramural. Of the public items that were published, the majority were data sets of many different formats, but we also saw figures, collections, multimedia items, software, and other resources shared in the repository. And they were all publicly open access, discoverable on Google, Google Dataset, Search, and more. We saw that the DOIs were included in publications so that researchers would reserve the DOI or publish the item in advance on NIH Figshare and then put it into either the data availability section or another part of their paper to make sure the DOIs of the resources were linked in the publications. And over the course of the one-year project, we saw views and downloads increasing over time. And actually, our largest month for downloads was one of our last months. So July of 2020 was a half month, but if you look at June of 2020, that's actually when we saw the largest usage. And this may reflect that lag that you see in academic publishing. So people share a data set, they upload it, they start to document it, they submit the paper for review, then it gets published, then people read the paper, and they see the data set, download the data set. And so all these metrics take time to accumulate. So we would expect that to grow over time. So when we look at the impact, everything in Figshare and NIH Figshare is tracked at the item level openly. So we collect views, downloads, citations, and alt metrics for each public item. And if there are multiple versions of an item, these are collapsed across the different versions. And it's particularly important that we have alt metrics as well, because the citations can lag, as I just said. And so here's an example of an item, actually not in NIH Figshare, but from Figshare.com, which has a very high altmetric score of 106 across many different areas, but actually hasn't been cited yet. And so having both metrics just gives a broader picture of how the work is being recognized and used. So at the moment, now we're about 16 months into the project, or since the project started. The views are now over almost 73,000 downloads of all the items in the repository, over 8,000, and we've now seen 44 citations of the work. This includes 6 items that were cited twice, and in all of those cases, it was a citation in the preprint and then in the peer-reviewed publication, which is interesting to note. Almost all of those citations, except for one, were the original self-citation in the paper describing the work that the data set or other items support. And that's where we have to say citations that are citations of true reuse by another party probably take a bit longer to surface. Another metric that we looked at was consider the value of metadata review. So this is a comparison of NIH-funded work on Figshare.com versus NIH Figshare. And so this proxy measure we're using is number of characters in the title and the description. And we can see that they're very much higher with the checked files in NIH Figshare. And then that's reflected in the metrics that we saw for views, and perhaps we would have seen that in downloads in the future as well. And I'm just going to go quickly because I know I'm almost out of time. which brings me to the final few slides, which are about the bibliometrics revolution for open data. And this is just the beginning. And we're starting to see really the impact of citation of open data. So this paper came out in PLOS earlier this year and demonstrated that papers that link to supporting data in a trusted repository, that those papers themselves have a 25% increase in citation rate. So it's not that by spreading out the different research materials to different DOIs, you're at all taking away citations of the paper. You're just making all of the research more impactful and more discoverable, and hopefully researchers are accumulating greater impact and citation use across then all of those materials. So one thing with tracking citations that we pay attention to at Figshare is that data is not always referenced the same way in publications, so people do not always put it in the reference list, and so it has to be treated a bit differently. So one thing that we do when we're gathering the citations metrics is search the full text of publications and preprints for the specific DOI strings of Figshare research items. And so this is important so that researchers can get the full impact for their tracking and funders can understand the full impact of their funding. And then these citations that we gather are then also linked in Dimensions, which provides an added level of discoverability and context. So you can see when you click through on the citations on an item on Figshare, it takes you to Dimension and shows you those, in this case, 2 publications that have cited that data set. And in fact, as I said, all of the data sets in NIH Figshare are indexed in Dimensions. You can search for National Institute of Health as the repository type, and then see those items and explore them further. So just one example of that is going a step further into exploring the research categories. So in this case, I have shown you the research condition and disease categorization, an NIH classification, which is not a metadata field that we had, but which is a metadata field that Dimensions helps extrapolate and apply to the data. So you can see that we had the most number of genetics data set, followed by vision, neuroscience, et cetera. So what's next for open data bibliometrics? I think there's so much we could do. There's a lot of questions about the best ways to apply these metrics and thinking through really what are the specific use cases that we want to answer questions for. So for example, do we want to think about the original citation versus the reuse citation differently? Do we want to look at tracking how people are meeting funder requirements for data sharing? Do we want to think about tracking data and code or other materials differently? So just to summarize, I think I'm out of time, but the main findings from NIH Figshare, a human curator to check the data for fairness is important. Custom metadata fields and funding IDs help track the research. Researchers did have a use for this kind of flexible generalist repository. And in terms of tracking data sharing, thinking about how you look for the full text of data set, searching the full text of publications for data set DOIs, checking that DOIs and fair metadata allow for that open data for discovery, reuse, citation, reporting, and impact tracking to get the full picture of impact. And this is just the beginning, and we look forward to working together with the community on this. And if I've run out of time to answer your questions, you're welcome to get in touch with me at anna@figshare.com. I'm also happy to stick around.
Anna, we do have a few questions in the chat, but I just want to ask one of them so that you can go back to the chat to do the following ones. So the one is about how the Figshare data sets are DOI minted and how is that being done?
Yeah, so we are a data site node. And so we can mint the DOIs through that. We can customize them for a specific portal or a client and reserve them in advance, and then they're maintained through DataSite. If a client has their own DOI minting, we can also apply that.
Thank you.
Yeah, thank you very much. And I will look into the chat.
Great. Thank you all very much. Thank you, Anna. And thank you again to all of the presenters. This does conclude day 2 of the 2020 Bibliometrics and Research Assessment Symposium. I will leave the WebEx open for a little while longer so we can clean up some things. But again, that concludes our sessions. Thanks again to everyone for such a great set of presentations and for being so active in both chat and Slack. And we'll see you back here tomorrow at noon Eastern. Thanks, everyone.